It is part of a bigger initiative called the Research Days, which is coordinated by the Research Council of Norway. And it's a place where to share advanced research and network with other young researchers. And as UiAdoc, we're very proud to be part of this. Each year has a theme, and for 2025, the theme is Trygghet in Norwegian, or safety security in English. Safety is a very broad topic and includes various different domains. Tonight's discussion will focus on one of these, which is technological safety, but will also include personal safety, societal safety, and much more. Together, among other things, we'll explore how humans and robots can safely interact, what are the cyber risks of the digital world, and even how AI could be used to control us. So it's going to be very interesting. The Young Researchers Night is organized in collaboration between UiAdoc and the Young Academy of Norway. And it's also sponsored by the Center for Advanced Study and Bergesens Stiftelse. UiAdoc is the organization for PhDs and postdoc at the University of Agder. And it's responsible for representing more than 450 members and for organizing social and academic events like this one of tonight. I'm now for 2025 covering the position of president of the organization. And during the night, you will have the opportunity to meet also the other board members, as each of us will be presenting a section of the night event. UiAdoc is a part of UiA, and none of this would be possible without the support of the university, and we're very grateful for this. So it's for me a great honor to welcome to the stage the rector of UiA, Sunniva Uitaka.
So much. It's a great pleasure to be here. This is an important event that I generally attend every year as a part of Research Week. David mentioned some of the activities that take place during this week. I'd just like to mention one other one, which is the Researcher Grand Prix. I don't know if anyone here was there for the regional final. But anyhow, I'm really glad to say I got back from Oslo this morning, but yesterday night our candidate won the finals, the national finals. So I think that really deserves a round of applause. Johanna who looks at the impact of sort of sports fishers in fishing lobster and how that impacts on the lobster population. So that was really great. The first time the University of Agder has won this competition. You may also know that we're part of a European University Alliance, and there will be an international final where Johanna will be representing us this year in Dijon. But I'd like to start by saying that I'm really, really glad that UiAdoc exists, because this is it's very important for you. Being a PhD student is quite a lonely endeavor, and having a place where you can meet across faculties, across disciplines is extremely important. You can share your experiences in a good way. Young researchers are extremely important for our university. You are the most international crowd we have at the university, and this brings so much diversity, and it's such an asset for our university to have such a diverse group of you are both PhD students, you're also both students and employees of our institution. Many of you will probably be working in academia afterwards. Many of you will be going outside academia and working maybe in a business or industry or in the public sector. But I think there is an increasing awareness that research is extremely important for the future of Europe. This is what the Draghi report points to, the need for specialized knowledge. There is a Norwegian version of the Draghi report called the Road to Growth, where they also emphasize the importance of having research. So you are really sort of the future of Europe in so many ways. And I really hope that your time here at the University of Agder is rewarding, fruitful, and that you feel at home in our community. We have, as a part of our strategy, we have the first objective is to be the students' university. And in that context, we include you as students. We would like to have you participate in shaping our university. So any type of feedback you might have on your study programs, on being a PhD student at the university, or any other thoughts you might have regarding our campuses, equipment, and so on, you know, we really appreciate your feedback in so many ways. So you've chosen a very timely topic for tonight's Researchers' Night, safety. Really, really important, and I think it's really important in our days also to think about these types of topics from a very interdisciplinary perspective. So I'm sure that you will be seeing many different perspectives on safety during this evening, and I'm looking forward to staying with you at least for the beginning of this night. So good luck with this lovely Friday evening, and good luck with your PhD projects. Thank you.
For your words, and here is a small gift for you.
Oh, thank you.
From the team organizing.
Thank you so much.
Thank you again.
I actually have one that I received 3 years ago that is blossoming at home in my kitchen, so it's looking great.
That's perfect. Thank you very much again. Okay, so as I previously mentioned, tonight's event is organized in cooperation between UiA, through UiAdoc, and the Young Academy of Norway. So therefore I have the pleasure to invite to the stage one of the members of the Young Academy, who is also professor at UiA in the Department of Management and Innovation, Anders Emil Tobias Otterbrink. Thank you.
Can you hear me well? Excellent. So, given the fact that the Young Academy of Norway is one of the founding organizations behind events like this nice one, I thought I would take the liberty to share some pieces of information when it comes to what the Young Academy of Norway is, what our main objectives are, and how we work. So we are a pretty new organization historically. In a couple of weeks we have our 10-year anniversary in Oslo in October. So we have existed as an independent organization for roughly 10 years by now. And I mean, the main thing with the Young Academy of Norway is to be a voice for people like you, young scholars, postdocs, PhD students alike. Currently, we are 40 members, spanning a wide range of different academic disciplines. We have members from physics, from mathematics, from medical sciences, from environmental sciences, marketing, psychology, etc. Everything in between. And we also have a quite nice geographic spread, so the member from the most northern parts of Norway right now is from Bodø, and I'm probably the most southern member by now from our dear University of Agder. We are selected to work actively on various tasks for a period of 4 years in total, so we follow the same logic as the Olympic Games if you want. And to qualify for being labeled as a young academic, according to Norwegian standards at least, we have an age limit of 40 years by the time you apply for becoming a member. And this is an open application process. So what is our main objective then? Well, as you see here, what we try to do is to act as an independent, interdisciplinary and diverse networking area, such that young researchers could have better working conditions. We work actively with things related to research dissemination and research policy. So in a nutshell, we want research to be useful, and we want research not only to benefit researchers themselves, but also to reach society at large to reach decision makers such that we will see research-based policy in our dear country. How do we work then? Well, we have a quattro stagioni format in terms of our working mode, in the sense that we have 4 meetings annually. We have one autumn meeting, which is the time where we introduce our new members to the Young Academy. We also have a winter meeting, a spring meeting, and a summer meeting. And of course, we have a range of activities in between those formal meetings. So here you see a couple of examples of things we do on top of those meetings. Tonight is a good example of an event we help to organize and co-fund, as well as, for instance, attendance and having presentations during Arendalsuka, or we have our own podcast. Here you see some of the important goals we have and additional activities we prioritize on a yearly basis. So one of the main events we organize is this Norwegian Young Researchers Contest, because we want that even children should be exposed to information about research such that they eventually, potentially want to pursue an academic career themselves at a later point in life. And yeah, at a more general level, we want to raise awareness, both when it comes to different obstacles and issues that exist for young academics, but also to, of course, work towards better working conditions and aspects related to, for instance, academic freedom, freedom of expression, as well as organizing those events related to research dissemination and sort of participating in the public sphere to have some influence in these political processes that shape how we as researchers, the reality we face and which potential issues we might face unless we raise our voices together. That was pretty much my 5 minutes in fame. So I thank you very much for showing up at this nice event. And I also strongly recommend each and every one of you who are interested in research dissemination, research policy, to apply the next time we have a recruitment round in the Young Academy of Norway, which is probably in May or June during the next year, because we have an urgent need for new members from the University of Agder. So please send in your applications if you want to work on these topics. Thank you.
Thank you, Tobias, for your presentation. Here, a small gift for you as well.
Thank you very much. Thanks.
Thank you. Okay, so now let's continue with tonight, and it's time to start with the scientific presentations. So, our first speaker is Associate Professor at the University of Agder in the Department of Engineering and Sciences. He works with robotics, mechatronics, and systems engineering. I'm glad to welcome to the stage Professor Daniel Hagen.
Is there any sound?
Yeah.
Yes. So thank you for your introduction. So I recently delivered the title for my presentation some hours ago, and then I saw all the speakers will include something with safety. So I had from AI-driven optimization to intelligent mechatronics, then I had to add building safety and intelligence into machine, not just adding it on. And that is what this presentation will be about. So my name is Daniel, and I'm the head of a new research group that we just started at Tech Real, that I have named Intelligent Mechatronics, or we just use the e-tron. And I'm also the leader of this motion lab that you can see in this picture. So, maybe some of you have seen my recent LinkedIn post, and I was also in Feven with a chronicle. But I'm looking a lot into that Norway, they excel in doing AI optimization of everything. But right now, we are forgetting how to build new machines. So what we are excelling at is that we use AI to optimize existing machines and systems and processes. We focus a lot on cybernetics. How can we control the machines smarter, adding AI into the control? We do predictive maintenance so that we get warnings when things starting to getting wrong with the machines, so we need to do maintenance. We do advanced monitoring and diagnostics, so maybe we can predict when the machine will fail. And we are doing a lot of data analysis in the cloud using AI. We put sensor networks on the machines, and we do a lot of remote operations. But what we are forgetting, and are not that much focusing on, is how can we build these machines from scratch? And currently, the ongoing trend is that only 17% of the students starting on the bachelor, they choose STEM, like technology and science, like we have on Tech Real. And that is the lowest of the industry countries. Only Brazil is below us. And my experience, at least in mechatronics, is that the new students that are coming, they really want to program, they want to control machines, making more cool things, but very few want to build something new. And then what I see, at least, is that the senior engineers that have been involved in the past decades, that have built these machines that we are using, at least at offshore, they are retiring, and the new people they're hiring is software engineers or AI experts. And in Norway, we have a big problem, because 5% of the money that Norway gets is coming from producing goods and manufacturing and creating stuff, and that is only 1/3 of the average in the EU. So if we need to get more money into our country, we need to produce some new stuff to sell. Right now, we are very dependent on importing solutions, and I will show some examples. So who is creating the new solutions for the Norwegian conditions? So maybe some of you, or most of you, should have heard about this oil fund that we have. There is some money in it, and that is because for the last 50 years we have built up the oil and gas industry, and there's a lot of money coming in that they have started saving. And that is because we build these machines ourselves. All the equipment that is on these drilling rigs is coming from Kristiansand. So we have 3 of the biggest companies producing drilling equipment are from Kristiansand. But there have been a lot of focusing on offshore wind, at least at UiAdoc. And we have continued. Some of the big oil companies, they are starting to do offshore wind. And they have some experienced engineers that are really good in building the platforms. They moor it to the seabed. They're really good at that. But then when they put on this wind turbine on the top, they need to buy it from Germany or maybe in the future China. And we have some, in this picture is one situation. So this wind turbine is not going out to offshore, it's going back again. Because the first Equinor, they built, right now there is 12 floating wind turbines. Because right now, if it's deeper than, say, 30 meters, they cannot put the wind turbine on the seabed. So then when they're going deeper, where the really wind is, they need to have it on a floating installation and moor it. And that's what's happening here. When they took a wind turbine that was built to stay on something that was fixed to the ground, and it was not, the gearboxes broke down. And 5 of the gearbox broke down at the same time almost, so they have to tow it into land, because we don't have any new solution for changing gearboxes and changing the turbine blades offshore. We need to take it back, so they use like 4 months in total to get them out again. So the problem starts when we buy the turbine and put them into these floating wind turbines, instead of getting this knowledge ourselves, like we did for the oil drilling equipment. So what do I mean with the machine? So I'm from mechatronics, so everything is a machine. and everything is mechatronics. At least if it includes some kind of actuators that make some mechanical system move, and we put some sensor on so we can like monitoring pressures and temperature. And if we have a complicated system, we can connect it back to a control system and make some automation happening. And this is put into a physical environment. So that is a mechatronic system for me. And then we put this into some kind of application, for example, a crane or something. And to control this crane, we have a human operator with joysticks, and then he sees when things move, and then he can control it. That's what we call operator in the loop. And he has some human-machine interface, the joysticks, maybe some screens and something, and then he sends them some control signals to the control system. So this is how most of the machines, like at least in offshore, when you're moving stuff, is done via operator. And then, when we want to go into more autonomous and intelligent machines, we normally want to replace the operator because we want to put in some automated controllers. And then we need to add additional sensors because when we don't have the human to see and do some actions, we need some smart systems to do that. So we add more sensors, camera, lidars, and then we need some algorithms and some computational power to be able to make some clever decisions and control commands to this real-time control system. That is the same as we used before. So, the industry, and at least the research that I know about from the mechatronics, are really focusing on how can we make these wind turbines that doesn't work for our condition, how can we make them work better, and how can we make the machines last longer so we can get the most money out of them. That's the focus. So they put AI everywhere, put sensors everywhere, digital twins here, digital twins there, predictive maintenance hype, endless pilot project, but few new machines. So there's a lot of optimization without innovation. So right now it's retrofit over redesign. Because today the company, they don't earn money on making something new because nobody buy it. So they earn money on digitalization. And that's where most of the R&D funds are going, is to AI, digitalization. Yes. So what I stated in my chronicle is that we will get a knowledge crisis because all the experienced engineers that built this system, they will go away. And the knowledge they have developed in these 50 years with the offshore operations will go away. So they will retire and we will lose how we can build these machines from scratch, how the machines behave, they have an intuitively understanding, how can we make new machines for Norwegian condition, because if we buy something for China, it's not built for the North Sea, for example. And how to integrate this with our system and other systems. They don't know if you buy a motor from Germany, they don't know how to integrate that with something else that we maybe have created ourselves. And what I see now, what this industry is hiring, it's AI experts, everybody is that today. There's a lot of focusing on robotics, software, machine learning, and data scientists. But what I believe that we need to be able to go into the green transition and get some really sustainable operations and machines, we need to build new ones. So we have a lot of research that we can put into, okay, how can we use this knowledge that gain and all these smart algorithms and sensors, how can we build this into the design? And that is the machines we need. And we need them for the Norwegian condition. So we cannot import this knowledge from China or somewhere else, because we need it for our conditions that the veterans know about. So we need to make the sustainable design from scratch, and it needs to be like into this circular economy. So that's why I created this Intelligent Mechatronics Research Group, and our vision is to be a leading in intelligent mechatronics research, driving innovation, blah, blah, blah. But our mission is that we want to develop new methods and new tools for the industry to be more efficient in designing new products. Because today, the new products, they need cybersecurity, they need digital twins, they need AI, And that is too complex for engineers today. So we need to make tools that can use AI to support the engineer to designing these. And these machines need to be intelligent, they need to be autonomous and sustainable. The energy consumption need to be very low. And here is this figure. So what we are doing is on the top, we are developing these tools or these methods. And what we get out is a physical design and the control system, or what I call the intelligent twin. And together, that is the intelligent machine that will contribute to this sustainable and adaptive operations. So the idea with e-tron is that we are building the intelligence into machines from scratch. So we use AI to build and not just optimize existing machines. So to do that, we need to capture the knowledge before these veterans disappear. And we need to develop these AI-assisted design tools that can help newer generations of engineers. And of course, there will be fewer engineers, as I mentioned. So these tools need to make sure that maybe one person can do what one team do today. So in parallel, we need to develop both the hardware and the software at the same time. And that is the core of mechatronics. It's not just sensors and actuators, it's software and hardware at the same time. And it's not just mechatronics, because we need information, so the idea is to bridge like the ICT and AI with engineering. So we have people from most of the groups and most of the departments at TechReal, and we also collaborate with some departments at NTNU, we also collaborate with NORS and USN. And here, one of the most important is that the needs and the domain knowledge is coming from the industry. We cannot sit and read papers and finding this knowledge that we need. That is in this industry, so we need to collaborate with the industry. And one example is one project I have now is that right now we are trying to develop the frameworks of how these intelligent machines should be. So the idea is that we will have some kind of distributed intelligent digital twins. So each machine or component that have a control system should have a digital twin inside it with some kind of intelligence. So instead of sending all the big data up in the sky, do something, it needs to be done on the machine itself. And then we distribute this into multiple machines. And by doing that, we get a more resilient design from scratch. So my tip here for you today is engage the students and the industry into your research. So student plus researcher plus these veterans is equal to innovation. So the veterans, they have the experience, the knowledge, the data that we need to make these tools. The researchers, we have the theory and we can learn or study all these AI algorithms that we can use, because at least at mechatronics we cannot just focus on developing AI, we need to use AI that other people are making, and we can say we want it adjusted or something. And then my experience is that the students, they have these really good questions that we don't think about, or the veterans don't think about. So the students bring a lot of inputs. So I will just share some potential or some opportunities you have to collaborate both with students and the industry. And I think both on mechatronics and ICT we have project courses on third semester on the master. 7.5 credits, and that is really nice because then you can design the master project, and then they can learn all the tools and all the theory they need, so when they start the master thesis they are more productive. They don't need to learn ROS for 2 months. And then we have also internship. Currently internship is for the industry, but if you have industry collaboration, you can bring the students into your industry collaborators with your problems that your common problems you want to solve. So internship, I also think in the future maybe internship should also be into research project and research groups, not just industry. I have at least tried, but they don't like it, not everybody. And then we have these students in research and in innovation project. Normally you can just have one, but if you are a bigger group, you can get many of these projects. And each project is like 20,000 NOK that you can use to pay the students or for equipment. So that is very nice. And also, of course, most importantly, bachelor and master thesis project together with industry. So here's just one example from how we can do it at the mechatronics. So when they have, the best is to get the students during the bachelor project and motivate them to take the master, of course. And then during the first year, you can use them into the student in research and innovation project. If you teach, you can involve them in project in your courses. Then, third semester, you have the project or internship, and then master project. How many of you have heard about UiAdoc? Not that many. But I have a side job to be an ambassador for UiAdoc, and my job is that if you get some kind of results, I want to inform you that if you have some kind of results that could be some innovation, you should contact UiAdoc, and there is a system for reporting this kind of innovation. And that, either it could be for the students themselves, if they really want to continue with this, or if you as a researcher, you want to maybe do something. And here is these two directions for students and for the employees. And I will focus on the employees. So if you have an invention that could come from the students, and they don't want to spend a lot of time starting a company, and in my case, often it's my idea originally, I just get help from the students, so it's my original problem. And then we deliver this declaration of invention to UiAdoc. And then the process starts. So if they like it or it makes sense, then you will have meetings. And right now we also have help from NTNU Technology Transfer Office that is really good and have a lot of people involved that can support to get our idea and results out to the industry or into products. And Research Council of Norway have a commercialization project, and these qualification and verification projects are, at least now, low-hanging fruits. So if you have some innovation or something that is based on some research results funded or coming from the university, you can apply first for qualification, and then you can get 500,000 to do some tests and maybe get money to apply for patent. And then if you get a patent, and then okay, I need to get this into the market, I need to test it in the industry or something, then you can apply for 5 more millions in this verification, and we are just got one last year or 2 years ago, last year. But there was also KSP, that is like knowledge creating projects or collaboration project where you can have the industry involved. And that's also a way to commercialize it. So I will just briefly go through my journey since I started. So I started in spring 2022. I started a new course and I needed some robots. And it was in the middle of this corona, and it was not possible to buy any of these turtle boats or something. And we have some really bad ones that was not suitable, so I had to use the equipment I had and buy from AliExpress and so on. So we designed some robots ourselves, and I did that with the master project. And ended up with a prototype, so I did most of the hardware and he programmed it. And he got a good grade focusing on that programming. And then I had some students in research and innovation project during the summer, and we ended up building 5 of these. And it ended up in a paper presenting this robot, using ROS2 and navigation 2. Then I needed more robots, new master project, new student project, 10 smaller, cheaper robots for just doing autonomous mobile operation. Then I needed a bigger one with the manipulator, new student project, and during just a student project in the autumn semester, they built this. And then we wanted to use this bigger robot together with a crane to do some kind of autonomous lifting and load handling operation between this autonomous mobile manipulator and a crane. And then, okay, if we want to do autonomous operations between an object we want to move and the crane and the robot, we need some kind of way to connect to this payload. Because the crane with the wire and a hook, it doesn't have any gripper. And we don't want to put batteries and actuators on this crane hook. So during this next master project, we invented a solution for this. So here you can see 6,000 years with dangerous manual hooking. Okay, there was some safety also here. But for 6,000 years, they have still doing humans to connect this wire or sling to this hook when they lift things. And like in 2025, when they have containers on these supply ships offshore, still people connecting the wire or the sling to the crane hook. So during this master project, where the focus was on the autonomous part, not making some mechanical things, because that is boring, at least now, but we needed some solution. So we ended up with this invention, and hopefully there is some sound, so I will show what we ended up with.
One crane, one robot, one goal, autonomous load handling.
There's no human there. So the two students, they got this new Best Master Thesis Award that we just introduced, and it's coming from this Norwegian Society of Mechatronics that I'm leading and started. So they got this, so they get 10,000 that we have from this society, we have collected from the industry, so we collected 10,000 from 10 companies in total, and they got that. And then we continue. So based on some further work, we developed this application for this qualification and submitted that during the summer, and we got that. And then, as a part of this qualification project, we wanted to scale up, because the claw that we had in the video was very small, 300 kilo max. But we wanted one for the bigger crane, so 2 tons we want to scale it up to. So I needed some master project, could be a bachelor, but I had one really good guy. I call him the 1%ers, the one that really want to design. So there's maybe one in a class of 20 or that want to do that. He don't want to code, he just want to do that. And they are really important. But the company don't want them, they need software people. So they still have some few mechanical engineers left that know everything. But 5-10 years, they will be away. So the next master project, they scaled this up and tested it for 2 different applications in the motion lab. And we also implemented, because we wanted AI, so we used some kind of vision with embedded AI in, and we did the training using this YOLO, you only look once, and to train it up to the shape and the color and of this ball and the claw. So when you detect this object, you get the pose or the position, so the XYZ position of the object you detect. So in this case, the claw and the object or the ball. And also it has this IMU to detect the pendulum of the camera that we mounted on the wire. So we could also use it for anti-pendulum. And then they get these camera measurements and they use it to do autonomous operations. I don't have time for more videos, but they installed upscaled it on this crane in the Motion Lab and also on this robot on the Stuart platforms. And they also did some heave compensation using this claw in and out. And they of course got this Best Master Project award, the second group. And yesterday we got this patent submitted, so that's why I could include it in the presentation. If not, it would be boring. So, it's your choice. Do you want to optimize the past or build the future? So, what safety challenge needs a new machine? It's limited how safe you can get it without removing the humans, and to do that, we need new machines. Which dangerous operation could be redesigned? I guess all of them. Will you add the intelligence, add it or build it in? And the e-tron solution is that we need to build this intelligent machine from scratch. We don't need to add sensors and add the supercomputers on top, because adding something on something that is bad from before will not be optimal. So we need to make these machines optimal from the start. And that's the way, for me, I think, to achieve sustainable operations, we need sustainable machines, and they need to be manufactured sustainability. And to build machines, we need machines in the factories, and so on. So, thank you, and let's build the Norwegian future together.
Thank you, Daniel, for your presentations and for your insights. Here we have also for you a gift.
Thank you.
Thank you very much, Daniel. Thank you. Okay, we have now reached the end of our first section of tonight's event. So we'll now take a 30 minutes break. We can go back on the room where we were earlier, and you will find snacks, drinks, and so on. And just one last thing before you guys go. Okay, probably most of us have already done it, but outside you will also find a stand with PhD students from UiAdoc, and they're collecting data for a research study about personality and food choices. So if you haven't done it yet, they will ask you to participate to a short experiment, and there will also be a food reward at the end for the one who are participating. So yeah, they need as many people as possible, so you're warmly welcome to join their activity. Alright, so thank you for now, and see you back in 30 minutes. Thank you, guys.
Everyone, I hope you enjoyed the first part of this event and also the food. Now we are ready to start the second section of the program, where we will have 3 speakers who will take us into their work and the impact they are making. Our first speaker is a professor from University of Agder at the Department of Engineering and Science. His research interests involve computer engineering, robotics, and also the interaction between humans and robots. So it's a great pleasure that I invite on this stage Filippo Sanfilippo, Professor Filippo, who is gonna talk about the complex relation between AI, robotics, and security.
Thank you very much for the nice introduction and for having me here. And so the theme of this event is safety, and in particular I will take you into a journey which is about humans and machines collaborating together. So in that kind of collaboration, safety is a priority. The title of my talk is Human-Robot Teaming, a forward leap into real-life applications. So the work that I'm going to present and the research that we have done, it's a work of several people, and without them, this presentation, this work will not be possible. So that's why I am always very proud of our team. In this figure, I've also summarized not only the people doing the research, but the research itself, and it's organized into 3 main layers. We have the core layer that is represented by robots operating in different environments, from aquatic environments to land to aerial robots. These for us are carriers. They can be used to carry sensors or equipment around for different applications. On top we have add-ons that we can add on top of the robots, like manipulators, grippers, and so on. But the core layer that we really focus on is this layer here, is the human-machine interaction layer. This is the layer that connects machines to humans. So let's dig into the core of my presentation today. I will first pay attention to this figure here, which represents a revolution. In the last 20 or 30 years, we have gone from caged robots, so robots in a cage, like you are in a zoo and you have, wild beasts caged there because they are dangerous for humans. Safety is a priority, right? So 20, 30 years ago, we had robots living isolated in a cage, and humans were not allowed to enter the cage because these beasts have very high torque, very high velocity. It's very dangerous. A potential impact with humans will harm people. So this kind of paradigm was still a big step forward compared to manual work. We can automate the process of production, especially for tasks that actually do not require humans. So for example, a production line, manufacturing cars or for the automotive industry. But later on, moving into human-robot interaction, we realized that there are tasks that actually require the involvement of humans. And finally, we started liberating our lions, our beasts, from the cage. We removed the cage, and finally, we start seeing humans getting closer to the machines. But at that point, there is still a virtual separation between the human and the robot. So basically, there are no contacts here. Moving on, we started looking at collaboration. So here, with human-robot collaboration, we have tasks that are finally done collaborating. So in a sequential way, most of the time. There is no cage, the space, the gap between machines and humans becomes smaller. And moving on, we literally see humans finally touching machines with physical human-robot collaboration. So for the first time, you see this progress from a robot in a cage finally touching humans. So of course, when we see this progress, the importance of safety will increase because now we have humans and robots really close collaborating with each other. But as you can see at this stage, the human is still in charge. You see this light bulb here in this figure? He's the one taking the decision, telling the robot what to do. Maybe grabbing the end effector of the manipulator, moving it into a certain point, and continuously collaborate with the machine. But what we are working today, what we envision, is this new concept of human-robot teaming. So at this point, humans and machines are sharing space, they work in the same space, they share forces. For example, one task could be to lift this table. Maybe this table is heavy, I need someone to help me, maybe the robot on the other side. So we will lift this object together. So we will share forces. And also we will share decisions. So who is in charge at this point? Is the human or the machine? It could be a shared decision process. For example, where do I want to take this table to? Maybe to the other room. So the robots need to understand my intention. So at this stage, it's not enough to to understand what is happening right now through the use of sensors, like we used to do with mechatronics, but we need to anticipate the intention of humans. We need to predict future. So to achieve this, we need three essential elements. We need better sensors not only on the robot itself, but also sensors on the human, so wearable sensors. We sensorize the human. We also need sensors in the environment, so in the room where this kind of collaboration or teaming is happening. And we also, the second point, we need better actuators, so motors that are designed for a very close collaboration where we share forces. That's why we are designing new actuators that are elastic, similar to human actuators. So if there is a collision, even passively, some part of the energy will be absorbed. And the last point to achieve HRT is better software, better algorithms. And today, finally, we are seeing this trend with the advent of machine learning algorithms and artificial intelligence. We finally have the tools to achieve better algorithms. So within this perspective, we are going to see applications into different domains. So for example, smart healthcare, cloud manufacturing, sustainable manufacturing, smart education, supply chain management, and disaster management. In all these applications, safety is a priority, since we have this close interaction and collaboration, teaming between humans and machines. The first example is within assistive health. So prosthetics and orthotics are one of the best examples where this symbiosis between humans and machines is realized. Actually here we have a cyborg, right? Partially human, partially machine. So within this kind of application, we have designed our own actuator. It's a new actuator that we call it hybrid because it's partially rigid, partially soft. It means that it's mimicking the knee or the articulation of the upper limbs like humans. So the motor shaft, we still use a rigid motor, but the shaft of the motor is connected to a torsional spring, which is engaged when we have a collision. So safety is achieved even when power is completely cut. If you remove the power supply, this actuator is still intrinsically safe. So, by the way, we care about releasing our research openly. You can download all the design and the software on that repository on GitHub. This is the exploded view of the actuator. So as you can see, it's all 3D printed. We use a traditional motor, and this is a simple elastic mechanism to make this joint partially soft. So of course it's a compromise between torque and safety. And here we have a demo I would like to show you where we simulate admittance and impedance control, which basically gives us an idea of how humans can interact with this prototype. So now we will see a collision with the human. And as you can see, this collision is safe. The robot will detect that collision and adapt to this situation. So moving on, at this point we have learned about the foundation of how we can build a manipulator. If we look a little bit at the industrial situation today, we have several vendors producing industrial manipulators, like the one from KUKA, these orange robots. And one of the main barriers that we see to achieve human-robot teaming and to open the software architecture for this kind of robots is the fact that vendors have this aggressive selling policy to sell hardware at a very competitive price, but then if you're a company and you want to connect different robots and add sensors, you need to buy software because they developed a proprietary software architecture. So that's why there is a chain here. There is a closed software. So to break this chain, we developed the first open source library for industrial manipulators. It is currently the only one available for KUKA robots in the world. And it works as a bridge between the manipulator itself and a computer program that you can develop on with an external software. So, just to jump into applications, I would like to show you two demos that use this library here. Again, interaction with humans. The first one is a simple interaction through a mobile device. This is done wirelessly, and you can control the manipulator axis by axis, or one of the main advantages to use our library is that you can develop your own control algorithm, your own kinematics and dynamics model. And then you can do a little bit more complicated things like use gestures to control the robot. And you can see in real time we can publish the sensor values and comparing the actual position and the desired position in Cartesian space and into joint space. So we are talking more and more, we are seeing more and more this close interaction between humans and robots. Here we can imagine an industrial plant where we have different workstations, right? So imagine like a plant where we are producing, I don't know, packaging milk. The operator could grab the package from one workstation, bring it to the next workstation, maybe for labeling or painting or doing another operation. So we have used a LiDAR sensor to monitor the position of the operators working in this plant. So the blue trajectories or paths are operators moving around. And based on this data, we realized that we can actually predict where the operator is going ahead of time, and then we can adapt the production to that situation. So for example, we can slow down one robot and avoid a potential collision. But with the same data, actually, you know, today data is gold, is the new gold. We realized that with the same data we can also do anomaly detection. So imagine a person that is not feeling well or simply feeling tired or needing going to the restroom. We can detect that anomaly and we can then adapt to that situation. And one more thing is, you know, people work with different locomotion gates. Each of us has a signature locomotion. So we realized that with the same data we can also do identification. We can identify the operator working in the plant. Of course, some of these things have very challenging ethical issues, but of course not all this is needed for all applications. So there are cases where detecting anomalies or identify the operator is required. So at this point we know we had an overview of how we can build actuators, how we can control manipulators, how we can adapt to different dynamic environments. So one of the main challenges to achieve human-robot teaming is the complexity of this problem, right? You have seen that it's not enough to know what is happening right now, but you need to predict the future. This is very complex, and especially humans are very unpredictable. So one way to achieve this, or to kind of cope with the complexity of the problem, is to move some of the complexity from the software or the algorithm to the mechanical design. So we can try to find a trade-off. So, and we can see this with an example. I would like to show you how we can build a manipulator. So if we look at the human end is a very complex system with more than 20 actuated joints. So it's very difficult to replicate. One possibility could be to find a way to scale the complexity up and down. So for example, if I am a company and I come to you, I tell you, you know, I want to package milk. Can you build a manipulator that is enough for me to grasp this package of milk? Maybe, you know, we don't need 5 fingers to grasp that package. Maybe 2 fingers is enough. In this way, I can design for you a manipulator that is low cost and it is also scalable. If tomorrow you come with another product to commercialize, we just, you know, we can add another finger if it is a bigger shape. So we can reuse the design. So basically, we have not invented anything. You know Lego bricks, right? Each of us know Legos. It's the same idea applied to robotics. Modular design, we have a modular palm that you can build by connecting together these bricks, and then you can attach your fingers on top and you can configure them in different shapes. And obviously the most interesting configuration is the one with an opposable finger, because this is how humans grasp objects, right? This is what differentiates us from chimpanzees, right? So by using this approach, we can build a manipulator that is a compromise between a simple gripper like the Festo kind of gripper and a more complex human-like manipulator like the shadow hand on the right side, which is very expensive, right? We are in between. Of course, our manipulators are not really human-like in the shape and design, but they are functional. So at this point, we know that by using the Lego idea, we can build a gripper. So how can we then use it with humans around? So we need a way to detect collisions. So here we have used a low-cost approach. We have hacked the standard servo motors by removing the case. You know, engineers like to take things apart. We have soldered an additional cable inside the internal potentiometer. Then we can read the change in current and estimate the torque, and therefore detect a collision. So at this point, we know how to design a manipulator in a modular way. We know how to detect the collisions. How can we then control it? And to do this, I wanted to show you this idea. You know this doll, right? In French, it's called marionnette. This is a very nice example that shows you that you have just a limited number of threads here, and through this you can control the movements of this doll, right? Multiple joints, just a few number of inputs. It turns out that this is exactly the way how humans operate fingers. So for example, if you try to take your index, please. Try to move only the last phalanx, only the last link. Can you do it? Maybe some of you are piano players. In general, we cannot do it, but if we repeat the same experiment by locking the first 2 links, just use the other end, lock the first 2 phalanx, lock them, then you can actually do it. So it means that mechanically our fingers are able to operate, to move the last phalanx. But it's our software, actually our firmware, I would say, that operates in this way, as in the marionette. If it is as if there was a thread, an invisible thread, that our brain is pulling and releasing, right? So that these 3 joints move together in a synergistic way, right? It has been proven by psychologists and biologists that actually this is the way how humans work. We have 2 sets of invisible threads. One is this, open and close, and the other one is orthogonal to the first set of threads and does this movement. By combining these 2, we can approximate more than 90% of grasping operations or movements. So this is very powerful. And by the way, why did I say that this is our firmware? If you have seen newborn babies, right? If you give them a finger, what do? They grasp it, right? So this is already there. They don't need to learn that. It's transferred through generations. That's why it's our firmware. And also it has been proven that this is not only the way we operate, but it's the most efficient from an energy perspective. It means that because of our evolution, we needed to survive with very little food. Norway, cold winters, right? We need a way to grasp objects that is efficient. And this is the way we have learned during our evolution. So by using this idea, of course, we can write, engineers like very elegant mathematical equations. I will spare these equations for this evening. I will just jump into the demo. So by using this idea, now we have a digital twin. So you see the visual gripper and the actual manipulator connected, and she is wearing a mind wave headset to read brain waves and control the gripper and grasp a balloon, which is a complex task because we don't want to squeeze the balloon. It's like grasping an egg. So in the next plot, you will actually see how it works. So on the top of this plot, you have the inputs coming from the headset. So it's alpha and beta waves. And down we have the torques of the motors going up when we have the balloon in between the fingers. So at this point, I know that the presentation is very packed, but I still wanted to give you a full overview of the research we are doing. So at this point, we know how to build the manipulator, how to control it from the human perspective to the machine, right? What if we can close this loop? What if we can give a feedback signal from the machine back to the human? This is what we will see in this demo with wearable devices, like this set of gloves that we have designed. These are Biltema gloves, but they are equipped with motors at the fingertips, and we are actuating the motors, making them vibrate when there is a collision, a visual collision in this case with the piano. So he's playing in VR visual piano and receiving the touch and the force feedback from pressing the keys. So imagine that you can use these kind of wearables to control the manipulator and receive a feedback of what you are touching. So touch becomes a very essential, important way of interacting with humans in this concept of human-robot teaming. And touch is also is one of the strongest sense we have in terms of safety. For example, when you drive in the highway, in the motorway, and you touch the edge, you have this vibration bumps. There is a reason, because you immediately react to that. You don't need to see, you don't need to process, right? So touch is very strong in terms of safety, and here we are using touch to train surgical doctors. So on the left side, we have our colleague Teria, who is wearing the device we have designed. We are recording touch. In the 80s, you probably are a new generation, but Sony released the Walkman. It was the first time humans could record music and play music in their pocket, right? We are doing this for touch. We can record the sense of touch, so what the doctor is doing and touching the human body, and the student here we will play the touch sensation, and she can learn to operate the same way the doctor is doing. So I'll show you this video. So there is no audio because I would like to explain what is happening. So this video has been recorded at the hospital simulator at UiAdoc in Grimstad. And here we can simulate different vitals for the patient. And the doctor here is going to perform what is called palpation and percussion on the abdominals. So she can then, all the forces are then recorded and transferred in real time to this other device that the student is wearing. This device is already a commercial product that a startup from Italy has developed, while the recording device we have designed. The resolution is quite good already. We can even sense the palpation. We can sense the pulses of the heart, the heartbeat. So, and this is part of a European project that we have with the University of Siena in Italy and Kaunas University of Technology in Lithuania and the hospital in Lithuania. So moving on to the last topic of my presentation today, again, safety, this conducting thread across all the applications that you have seen today. We are working with the Center of Emergency Management, CM, which is another research center at UiAdoc, to develop a robot that is inspired by nature and looks like a snake. Why do we want to do this? We want to use the same capability of a biological snake, you know, operating across different domains, navigating through sand, climbing trees, flying, even gliding, swimming. If we could mimic this with a robot and give this robot to our first responders, we would have a very strong tool to save life and to increase safety of people. So to do this, we have provided our own definition of perception-driven obstacle-aided locomotion, because this is a very special robot. With a normal mobile robot, like a robot with wheels or tracks, you normally want to avoid obstacles, right? You don't want to kill people, you don't want to collide with obstacles. But with this, you actually want to have collisions. It's the only way for the snake to move forward. We can use our own body to push against obstacles and propel efficiently. So this is the robot that we have designed. It has a modular design again. It has the same actuators that are soft and can be 3D printed. You can download the design and you can assemble it at home. So this is the last video. At this point, again, within the concept of emergency management and safety in emergency management, we are also using robots that are quadruped robots, so robots with 4 legs, like the dog, and we are training them to use their senses as, you know, a rescue dog. A rescue dog has a very developed sense of smell. Here we are simulating the same with lights. So the robot is able to detect a light source, find the direction and converge towards the light, as if there was, you know, a rescue dog using its nose to find a survivor in a collapsed scenario. So we have tested this in simulation and then with a real robot from Boston Dynamics. So here we are testing actually sound, but you know, sound and smell are very similar or comparable. So we have added 16 microphones array on top of the robot. The student is clapping, the dog is detecting the direction of the sound and converging in that direction. In this situation, you can imagine the application. If this building collapses and there are survivors, we can send the robot. If the survivor makes noise, the dog can detect it and converge towards. And of course, we are also integrating other kind of sensors like thermal cameras to detect the emitted heat from the person, combining multiple sensors to increase safety. And this was my last slide. So I'll be happy to take maybe at least 2 or 3 questions. Thanks. Maybe someone? Any questions? Any comments? Any critique? Please.
How long is it currently applicable, the collaboration that you're speaking of?
I cannot hear you well.
Thanks Thanks for the nice presentation, Philippa. It was very nice to listen to that. How much do you see it being applicable in the current industries at this moment? Can you see the transition nowadays as well?
Yeah, so it's very hard to answer this question, but I would say that we are definitely transitioning. And again, there are tasks that do not need human-robot teaming. All the tasks that can be fully automated don't need this. But there are tasks, and especially now with the advent of AI, where humans and machines need to collaborate, right? So I'm talking, for example, your field, batteries, right? Disassembling batteries. You have a plethora of modules. It's not possible to fully automate that process. You need to have a way to transfer knowledge between machines and humans, and vice versa. Maybe at some point the machine, has seen enough modules that knowledge can be transferred back to the human, right? So there are tasks, and there will be more and more tasks. I'm thinking even about art, right? An artistic process like painting. We have seen robots used for painting, but it's not really painting, it's like a 3D printer, right? You can see the mechanical way of using a brush, but painting with a technique. So for example, oil painting, it's not there. There is no robot yet that can do oil painting, right? That kind of task will require this kind of approach, like transferring knowledge, right? Control the pressure of the brush with the expression, with the emotion, right? That's not there. I think it's going to be the next frontier, but here we're talking about work for 50, 100 years, yeah? Hopefully, so until I'm retired. Thanks. Maybe someone else? Okay, good.
So our second speaker got his PhD in June 24, and now he's currently a researcher at the University of Agder in the Department of Information and Communication Technology. His main research interests involve deep learning, computer vision, and monitoring application. So it's with a great pleasure that I invite on this stage Dr. Mulugeta Asres, that is gonna talk with us about safety monitoring solutions.
Okay, thank you. It's a bit hot here. Okay, today I'm going to talk about, of course, a lot of people are talking about AI. So our main focus is going to be application for security, but the main focus is going to be also privacy. So this is part of our project, which is the AI for Citizens for Responsible AI, which is a collaborating project. Several partners are currently participating in. From academia, you are NTNU are basically developing the technical solution across different applications, and we have also BI working on the social impact of it. And from the regulatory, we have the United Nations and also industrial partners such as the, of course, the Norwegian police, the Dutch police, the UK, and one of the tech big players there. So without further ado, so basically the core idea here is security and privacy are like the cornerstone of like a thriving society. And these are like two sides of same coin. They are intertwined, intricately linked together. And the problem is very difficult to get the right balance of it, because we need a robust security that protects privacy, and at the same time protecting privacy can foster like responsible security practice, and as well as like accountability. So with over 1 billion cameras, CCTV cameras all over the globe, industry, regulatory bodies, and as well as also academics are kind of jumping in to this area, but they are trying to get this sweet spot in which they balance like the security as well as like at the same time protecting the privacy. So in this particular talk, we are going to discuss like the current state of the art solutions for anonymization, which is a technique that we use for de-identification of privacy sensitive activities from CCTV videos. And we're going to discuss also, we're going to have a couple of demo results in which we apply anonymization as well as the video anomaly detection in order to detect alerts or like security or safety related alerts. So before going further detail, I would like to briefly highlight the potential solutions in which we can use advancement in computer vision. What I mean is like AI-based computer vision for public safety monitoring. So you can have like several applications. We try to categorize them into two, basically like individual or personal based applications, or like crowd-based applications. And we can have like, it can be a kind of a static safety alert. For example, if somebody left a bag, or like a kind of, as you can see in airports or like shopping malls, that can be a kind of security threat. And you can have also like with emotions. For example, somebody is trespassing, or like somebody have like an intense of terrorist attack. Or for crowd monitoring, we can analyze the behavior of the crowds, basically. If there is any kind of a panic there, or based on the interaction between object to object or like person to object, is more or less the premise of the study. So as you can see, most of the applications, you don't need to process your private information. Of course, there are some, for example, facial recognition. If you are going to track like a person of interest or a missing person, you need to see the face or the individual. You need to identify it. But most of the applications, they don't need to do that. So that's where the core idea comes in. So we don't need to process the privacy. So we need to have a way of anonymizing or de-identifying the sensitive information, but at the same time keep the utility which is relevant in order to trigger or detect the alerts in time. So at the core of the project, we have a computer vision. Of course, also we have kind of using some sort of language modeling. Then in the application is to have a video-based anomaly detection for monitoring application. Of course, we need this one, a kind of a real-time processing. We need to have the alert in real time. That means we need to improve the response time to the incident. So then for privacy protection, we have a visual anonymization techniques. So the idea is there are two sides. We have the automation. Basically, why we need the automation is we have, for example, currently thousands of CCTV, for example, here in Norway. So maybe for few CCTVs, currently they are using it like a kind of retroactive way. So at the dashboard monitor, there is this police operator looking at the screen, trying to monitor what's happening on particular sensitive areas. But this can be done like for a few CCTV videos. It's very difficult to monitor at the same time hundreds or thousands of CCTVs. So since it is like not a scalable solution, the current solution is they were using like for after something happens, something critical happens, they try to go to the log, of the video log, and try to see what happened, try to investigate basically. So they don't have a kind of a real-time streaming alert detection mechanism. So that's where the automation or the deep learning with the AI comes in. We can have like a scalable solution. We can instantly monitor thousands of CCTV at the same time in real-time system. So the other side challenge is the privacy side, which is, of course, we have a surveillance. So there is a huge privacy concern here, and whoever have this technology will have also like more power and control. And of course, the regulation is already catching up this. We have the GDPR, the EU AI Act also concerned about these applications, and the model biasness. So basically, these models are trained on publicly available internet data. So this data is not clean. There is a lot of biasness there. So the model can make a mistake, basically based on your private information, your racial profile, or gender, or age, can can result in a wrong prediction or wrong detection. So this model biasness is also a big concern as part of the negative or the challenges we have for such kind of automation systems. So to quickly discuss to review the potential CCTV, the anonymization approach, starting from the simplistic one, which is the lightweight or conventional techniques. You can, for example, kind of blur the face or the body, or like pixelized, or a kind of, or completely kind of, you can use some sort of like slow-tay kind of technique. And these are lightweight and computationally efficient techniques, and we can have a deep learning, which is also generating a fake synthetic image on the video. So we give a kind of a new identity. So these are more or less the currently available solutions, but currently we are more focused on the lightweight approach. So this is the overall approach we are currently working on. So we have the CCTV raw footage. So we apply the anonymization block, in which we focus on the target human subjects and completely, for example, here we are using the masking, completely anonymize them, and we apply the anomaly detection model, in which it detects like the alert part of it. So there are also other metadata we are currently working on in order to generate what type of alert it is, what the confidence, and try to explain the scene so that the police can have more context to the alert. So here I'm providing an example demo. For example, we have a burglary here. So the left side is without any privacy protection. So he's breaking into the car, and the alert you can see in the video, which is the red dot when the alert is happening. I need to play this one again. So with anonymization, when the person is anonymized, the third one is when the car is all anonymized, which is we try to protect the plate number here. But still, in the data solution, we are able to detect the alert even if the person is fully anonymized. So this is one of the solutions we have developed. And the other lightweight approaches, of course, we can use this full body masking, but it also affects the video quality. So we are exploring like the blurring and pixelization technique because they are lightweight. But unlike how the commercial products advertise them, they are not that much secure enough because they can leak your private information, and at the same time also you can identify the person even if they are blurred or pixelized. Why is because one of the reasons here you can see the image. For the person, this is a pixelized and the right side is blurred. The person which is closer to the camera is not that much protected, and the people are far from the camera as they kind of disappeared in the image, as you can see. So we developed a technique that is a kind of an adaptive, which is by considering where you are on the camera, the anonymization basically adapts or dynamically assigns the protection. So it balances the protection as well as the keeping the quality of the image or the video. So we call it the adaptive anonymization approach. So more example, for example, we have the left side, which is the raw video and the raw images, and this is the traditional conventional pixelization, and we have the updated, which is the adaptive technique, which has like able to cover or protect the person even they are close to the camera without destroying the people that are in the background. So just to have some qualitative assessments, we run the experiment on a dataset containing 1,500 people. On this data, there are like 6 cameras for the same person taken from different angles from different locations, and we are trying to see whether we're able to identify the individuals here. So without any protection, the model was able to kind of detect, for example, with the MAP metric around 0.82, and with protection, like with fully masking, we can see we have able to protect 98% of the detection. So this is a full masking. But one interesting result you can see is for the blurring and pixelization here. Depending on the setting, the protection is like from 3% goes back to any up to the 6%. So see, even if you are pixelized or blurred, still the computer can still identify the person. So with our adaptive technique, that security is significantly improved as compared here. You can see we have from 80 to 95 protection rates with the dynamic technique, basically. So one interesting part here is, even if we anonymize the people, we are able to detect the person, even if it's fully masking technique, because of the object they were holding. So this was an interesting finding. So based on the object, the model was able to detect or identify the person. So as you can see, the model is focused more like on the objects, even if after the anonymization. These are fully anonymized, like a black coloring, but still the model is where it's focused on the objects in order to identify the person. So by including the object into the anonymization, we are able to increase the protection from 80 to 98 to up to 99% in the anonymization accuracy. So the second part is assessing the potential of the anonymization, how much is the degradation, because we are affecting the video quality. So we would like to see the impact on the alert detection. Are we still be able to detect the alerts even after anonymization is the core question we are trying to answer here. So most of the models were able to achieve like less than 3% degradation. So it's quite pretty much good and still able to detect the alert at the same time while achieving privacy detection. So in this particular dataset, we have 13 different public related safety categories. So we have more results even in our reference papers. So, but it's an interesting result to see also with our adaptive techniques, even if we have a significant improvement on the privacy protection, still the degradation in the alert detection is quite small, which is less than less than 1%, I can say. So as an example, we would like also to kind of demonstrate on a video. So the first video here, as you can see, is which is taken from a movie which is demonstrating a shooting. So you can see different anonymization techniques are applied here. So how the model is triggering the alert, you can see on the picture here, which is the yellow-orange color which is the true labeling, and when the score is increasing, basically that means there is an alert detection. So this one is people are fully kind of covered or anonymized, but at the same time we are able to kind of spot the alerts. So in the second example, there is a person which is like breaking or burglary into the house. So the alert is the system is able to spot even if it's fully anonymized. So yeah. So as the last part of the slide, so we have also developed a dashboard which is publicly available, in which users or partners can experiment and play around with different settings. You can directly access to your webcam or like an IP camera, or directly also access a YouTube link to experiment with the model, and you can see you can experiment with it and try to evaluate how the system behaves across different conditions. So I just play here just for demonstration purpose. These are two people demonstrating fighting with a knife. So you can see how when the system detects and generates the alert, and we can have this logging score. And yeah. So this dashboard is aimed to accelerate the collaboration among partners. Yeah, so you can play around. If you can go directly to the link, you can experiment with it, and yeah. So I hope I'm in time. So thank you for listening.
So we now arrived to our last speaker for this section, and he is currently a PhD working at University of Agder, working on T-settling machine and natural language processing. But this night is gonna talk about something more close to the main topic of this young researchers night, that is safety. He's gonna talk about something that everybody should be aware of. That is how to protect ourselves across the web. So it's my pleasure to invite to this stage Hamed Kadim.
Yes, hello everyone. This presentation is not directly related to my work, as Maria said, but it's within my industry experience, where I worked as a system developer and IT system administration. Today I will highlight some key points that is important for any user while he uses the internet and browsing. So every day, every time we want to navigate to a link, a URL, we either click or we type the URL, or sometimes on our mobile phone we touch the link we received. Now, this click, press, type will open up a web browser on our device, which is either mobile or laptop, and then this application will call a link, the content of a page that sits behind this link. And today I will focus on this part of the story, which is, and I can translate this call link page to request a domain content. So this story will cover how requesting a domain content happens in our devices. So as the previous slide, our device will send a URL request to fetch the content behind this URL, and then we receive the content to our device to see the page on the screen. This is a very typical stereotype about how the internet works, but in reality this is not the case, and it's way more complicated than this. And in order to, there are many steps going behind the scene, but in order to understand what we need to know in our device, sometimes to change the settings, I will divide the steps to two very important steps. And in particular, I will add one additional step, which is the first trigger step. At the beginning, your device will resolve first the domain name. And that means you first will ask, where is this URL sitting? So you want to open google.com. You first have to know what is the network address for this google.com. And this type of mechanism called domain name resolving or domain DNS lookup. The server responsible for this called DNS, and he will reply by sending the IP address for this domain name to our device. And then next, our device will request from this IP address, which is the content server, the content of the page. So instead of having one step, now we have two steps happen when we are opening any link in our device. So what is the DNS? The DNS is the Internet Address Book, and who owns the DNS in your network? If you are in the campus, or if you are in an airport, or if you are a building with data center, then the network operator who is the responsible for operating this DNS. If you are at your home using the internet, using the Wi-Fi, or if you have a mobile your mobile phone with internet service, then the ISP who is responsible for this DNS server. Also, if you decided to change these default DNS server, then you can pick one of the commonly used DNS providers such as Google or Cloudflare. Also, you can run your own DNS in your own network. Now, how this DNS series? Imagine you requested a website and you redirected to a fake website. You requested google.com and you redirected to a page. Seems like google.com, but in fact it's not google.com. This is called a phishing malware attacks. Also, imagine your ISP or your DNS provider tracking your traffic. He's counting how many you visited google.com or any shopping website, and then create a user profile based on your traffic, and then attack you by an ad or any kind of idea. This is one of the possible scenarios also. Also, sometimes it's not very dangerous, but it could be useful. Like in Norway, there is law to force the ISPs to prevent users from accessing certain websites, such as some gambling sites. So they use the DNS to do this. So these actions are handled by using the DNS. Going back to the second step, which is fetching the content, it has also possible scenarios, issues, and it's a little bit more complicated. And because of the time constraint, I will try to cover this within the possible scenario, possible solution we can take to improve our security or privacy while navigating in the internet. So, how you protect yourself? I will start with the simple actions. First, check before you click. Hover the mouse over the link. Sometimes it shows you eBay.com, but in reality it has different content. Sometimes you see a link which is, for example, in Microsoft.com, but it's not M, it's R and N. So check before you click. Also try to click only URL end with S, and that means your connection, your traffic will be secured, will be encrypted. And if you selected HTTPS, pay attention if you got such a warning, because maybe the connection is not encrypted with valid certificate. Also, try to type the link by yourself. Don't just click. Use trusted sources. For example, here any domain end with .no. It is not 100% safe, but it has some because the way they provide this domain is way more complicated, so you can't trust most of them. Also, don't click suspicious short link. There are some online tools that can expand the short link and show you exactly what's the real link. And keep your browser or internet tools updated. Now let's jump to the more advanced protection action. I will start with the option that is available in your device. In any Android or iOS or Windows device, there is something called randomizing my MAC address or my device address, my device network address. This option is very important. Whenever you connect to network, the network will ask what is your device address. And by activating this option, your device will generate a different address each time you connect. So try to activate this. The second option, which is the DNS, as I said before, if you want to bypass the default DNS provider in your network, simply you can type one of the famous DNS IPs, such as 888, which is by Google, and 8844 also by Google. And there is another one which is 111 by Cloudflare. I will cover it in the next slide. The other available option, which is proxy. Proxy is a simple form of the VPN. So you should have another server that you pay for it or you get it for free, and then you connect to this proxy, and this proxy will take your traffic and navigate to the internet. I will cover this in the VPN section. Okay, so beyond the default device settings, we can take extra steps or action to protect our navigation in the internet. You can secure your DNS request. And one of the famous applications do that, which is 111. You can install this application on your phone or mobile or PC, and then your DNS request will be encrypted using a protocol called DNS over HTTPS. So know that the default or your network DNS provider cannot see your request, cannot track your activity in the internet. Another option, most of you know about the VPN, which is basically a service you pay for it, and then you get a VPN server, and all of your traffic will go via a tunnel, encrypted tunnel, and then your traffic the two steps will start from the VPN server instead of your device. So anyone in the internet cannot track or see what you are requesting or who you are. More complex, advanced technique, which is the relay or hubs. If you have iCloud Plus subscription, there is an option called iCloud Private Relay, which is basically a service that Apple provide, and they add two relays after your device. So your internet browsing will go through two steps before go to the internet. And by adding these two steps, no single entity in this network will know exactly about the traffic. So Apple will know your device address, but doesn't know your requesting, because this is the responsibility of the second relay. More advanced, more complex than this network, which is the Tor network, they use more than two hubs or two relays in order to send your traffic to the internet. And this is a free service, and it's a voluntary network. You don't need to pay for it. Okay, so if we want to compare DNS, your ISP will see the website you want to visit it, and he is the responsible for redirecting you to the website. So they are the ownership of the DNS. It is very fast, it is built-in, default, you don't need to change anything. Secure DNS, your ISP will not know about your traffic, your requested, but they can see about, and your traffic will be encrypted, so they don't see anything. But then it has more complex steps, you have to change something, and it's supposed to be very fast for some services like 111 service. The proxy, which is the less secure option and require additional steps you should take, you should buy a service. The VPN can be a nice option, but be careful, you have to trust fully the VPN provider, because they will see everything from your internet navigation. The relay or hub, which is the strongest one, no one knows about you, but you have to install or set up more settings, and of course it is the slowest one in the options. Yes, so in summary, remember, next time you click any link, you type, there is no more one step, there are many steps, and the two important steps are, the first, you are resolving the domain name, you are requesting for the real physical address of the server, and then you connect to this server to fetch the information. Thank you, and this is mine. This is yours. Okay.
So now we will have a short break before the third section. That's what I said.
Okay, welcome back guys. I think we're good to start now. So our next speaker works as a researcher at the Department of Engineering Sciences in Grimstad. Her research focuses on battery safety and advanced energy storage systems. And specifically her research is to prevent thermal runaway in lithium-ion batteries and to improve thermal safety. So please welcome onto the stage Agder.
Thank you. Hello everyone. My name is Agder, and I work as a researcher at the University of Agder. And this is my topic of presentation: preventing thermal runaway and safety in modern battery system. Before I begin with this topic, I would like to thank Young Researcher Night's organizer for giving me this opportunity to present this thermal runaway topic here. Thank you. And let's begin with this presentation. So these are the contents of my presentation. First, I'll be talking about the batteries, and then like how it feels like. And then I'll be talking about the lithium-ion batteries, like which kind of reactions taking place at which and charging and discharging. And then what is thermal runaway, how it's happened, and what's the reason of it, and how we can avoid it by detection and prevention techniques. And then we will be discussing about the emergency protocol, in which like we will be discussing what to do and what not to do. And at the end, the conclusion. So if I say batteries are like human, do you believe me? So I have actually analogy for this, like human and batteries, because the batteries are also like humans. They hate to be like overworked. They don't like extreme temperatures. They are fuzzy about the external pressures, and they are diverse in chemistry, size, and shape, and they are also statistically faulty. And they grow waistline as they age, like humans, and cell also breathe, like they expand and contract while charging and discharging. And the ultimate truth of the humans that we die, and hence the cell dies. So here we're talking about majorly on the lithium-ion batteries, because our focus is on the rechargeable batteries, and it has like a really high this energy density. That is why we are focusing on it, because we have like, let's say, a phone that we want to like run the battery or the phone for a longer period of time. So that's why we are trying to increase the energy density of the battery, and that is also creating an issue that we will discuss later. So for now we are actually working on a lithium-ion battery, because it has really high energy density. It is really high energy density. So this is like a normal, just talking about like here, very normal battery, like anode, cathode, and separators there, and the current collector at the end. So if you see the reactions, what is taking place, anode is like just made up of like graphite layers, and cathode is made up of like lithium metal oxide. So what happens when we charge the battery, then the lithium ion goes from the cathode to anode and just get intercalated inside the graphite, and vice versa happens when we discharge the battery. So these are the reactions taking place while charging and discharging. And when these reactions are taking place, there are like different kind of heat generations, reversible heat generation, irreversible heat generation, while charging, discharging, and which can lead to the temperature rise more than 60%. And then what happens that it is like increasing the rate of reaction for the electrolyte breakdown and the damage to the separator and the rapid discharge of the battery, which will again lead to the temperature rise. So it's like a domino effect, one leading to another and another leading to the next one. So I mean, we performed the experiment of the thermal runaway. I mean, for this we need to have like a lot of clearance, and this is how it looks like when one battery goes through thermal runaway. Yeah. So here thermal management comes into the picture, which tries to maintain the temperature of the battery under the permissible temperature limit. That's the objective of the thermal management. And this is, just imagine if it is like burning like this for a single battery. Just imagine if you have like battery pack of like 7,000, more than 7,000 batteries in it. So what can happen here? This will look like this. So none of us would like to burn our car like this, so we need to take care of the batteries properly. So why would it happen if like, what's the reason for the thermal runaway? So first, I mean, it can happen with the like overcharging or over discharging or nail penetration, or if you are damaging the battery, mechanically damaging the batteries, then it can happen. And let's say one battery is burning in it, and then it will like transfer heat to the other batteries surrounding, to the other surrounding batteries, and then which will lead to burn the whole pack. That was leading to that kind of thermal runaway scenarios. And for that battery management system comes into picture, where it works as controlling. The objective of this using battery management system to ensure the safety, performance, and the longevity of the battery pack by controlling the voltage, current, and temperature of the system. So the benefit of this using is that we will ultimately optimize the performance of the electric vehicle with the help of this BMS. And the another part of the BMS is battery thermal management system, in which we are only controlling the temperature of the battery pack, in which there are different methods. We can work on the active cooling, passive cooling, and the hybrid cooling. So this was my actual PhD topic, but here I'm just giving one slide presentation here. So in which different an active air or liquid cooling can cool the battery pack so that it doesn't exceed the temperature of the battery more than 60, or depending on the chemistry of the battery. So to avoid the thermal runaway. And the passive is using the PCM or heat pipe, and the combination of these. So there are different detection and prevention technologies. So first is using the different kind of sensors, which is continuously monitoring the critical parameters to detect the deviation from the normal operating conditions, and in which there are different kind of sensors like temperature sensor, pressure sensor, and gas sensors. And the next is AIML for early fault detection, in which we used to analyze the sensor data to identify the pattern that indicates the potential future failure, and allowing for proactive maintenance. And the next is fail-safe design. What if one battery fails and we got to know, and then what we can do and how can we stop the propagation of the thermal runaway among the whole battery pack. That is what fail-safe design. To ensure this kind of safety in the electric vehicle, there are different standards for the EVs, which is regulated by different organizations, which is there. And now we are talking about how to prevent thermal runaway. So we need to charge, for this, charging is really important, plays really important role. We need to charge with the right equipment. It should be correct voltage, current, and these things should be maintained. Right? And next is we should charge in a safe location. Safe as in it should have some conductivity. It should not be on a hard combustible surface, which will be able to catch the fire and propagate it again. And next is monitor charging. If it is fully charged, then just turn it off and do not leave it forever, like for charging. And last is disconnect after charging. So it's the same thing, like if your battery is charged completely, then just disconnect to avoid the thermal runaway kind of conditions. So what are the emergency protocols, what we need to do when we have this kind of experience? So pull over safely. We need to park the vehicle in the safer place where we are not going to affect the others with this kind of scenarios. And just get out of this car, and that's the first thing you need to do. The second thing you need to do after parking the car, and then move to safe distance from the car actually. Like that is around 100 feet or 30 meters you can say. And call emergency services, dial 112 and clearly state that is electric vehicle fire. And warn other, if they are like watching this and then going to touch it and something, then just warn others to just stay away from the car. And what not to do. This is really important, that we don't have to be hero at that moment when the car is burning. So do not try to extinguish the fire, because if you try to do that, then it's not a normal wood fire that will you can extinguish with the normal water or something, because it's a chemical fire. So you need to have huge amount of water that is difficult to get at that place, And next is, do not try to retrieve your belongings from the car. You have to leave those things, because if you want your safety for yourself, you need to leave your belongings in the car. And do not touch the vehicle, because it can cause your electric shock or reignition of the system. And the burning of these batteries actually produces lethal vapors. So we try to stay away from it and try to avoid this. And here's the conclusion of my presentation. I was just talking about the failure. So you might be thinking that it is meant to be failed, but it's actually not. Only 1 in a million battery just failed. And next is prevention first. Robust BMS is essential to minimize the risk of the battery failure. And then proactive safety is really important for the battery pack. And the last is just we need to be prepared. Whatever happens, if it fails, then also we need to know that what we need to do, and for our safety and our society's safety. That's all from my side. Thank you everyone for hearing me patiently. Thank you.
Thank you very much, Agder, for a very enlightening and learningful talk. Thank you. So for our next and final speaker, we also have someone from industry working with cybersecurity. Simen Bai is a senior penetration tester at River Security. He specializes in offensive cybersecurity with 4 years of hands-on experience in penetration testing, which will also be the topic of his talk. So please welcome onto stage Simen Bai.
Yes, so today I'm going to talk a little bit about modern penetration testing, or being the advanced persistent team. So a little bit about me first. So this is me. As mentioned, I work for River Security. I am an offensive security penetration tester. I work in the offensive SOC, which I will talk more about today, and I also do incident response, and I'm a lecturer at UiAdoc. So, first off, why do we do pen testing? So, there can be a number of reasons for why we do pen testing. It could be for because we're releasing a new system. It could be because we are trying to gather some information for compliance. Maybe we want to do risk prioritization. Maybe we want to just identify security weaknesses. But do the tests achieve what we actually want them to achieve. So sure, penetration tests are great in the short term, but it doesn't necessarily address the long-term security risks of the organization. And that is because traditional penetration tests are often only a snapshot of the infrastructure. So what happens if something changes tomorrow? How can we make sure that the security continuously gets improved? So that is kind of why we figure out a new way to do things, a new modern way to do things. So we have this problem with traditional pen testing that we only really get a snapshot, and most companies, because of they're just doing it for compliance reasons, usually only have 1 or 2 pen tests a year. So since traditional pen tests only give a snapshot into what issues are at that date in time, they don't know what happens the day after the report handover is done. So they can go half a year. If a change is done the day after the handover report, or the report handover, it can go half a year or a year before they discover that security vulnerability that has been introduced. So this way of testing things can create a false sense of security. Organizations might believe that they are protected until the next scheduled test. They might think that they don't need to look into those new things that are being implemented, because we're going to have a test in half a year. And they're really overlooking the continuous and rapidly evolving nature of cybersecurity threats and their own continuous evolving infrastructure. And the security landscape can change very drastically in just a few months, let alone a year. So making frequent reassessments necessary to actually safeguard the information in their systems. But that isn't the only problem. Traditional pen tests also have a very narrow scope. Often you hear, you can only test this one specific system, which essentially guarantees that the shadow IT, aka those systems that are unmanaged and have been forgotten about, will remain shadow IT, so they will keep being forgotten about. Furthermore, traditional testing suffers from a lack of understanding of what the real risk is. The test will often focus on systems that the organization knows about, that they care about, that they think is important, but doesn't necessarily address the shadow IT, enhancing the problem even further. But by not including all the potential threats or points of vulnerability, organizations miss the opportunity to identify and address those risks that could be exploited by an attacker. So that is kind of why we have changed how we do pen testing. So instead of having the traditional pen test that's each 6 months maybe, we do what we call offensive SOC, which is basically continuous monitoring of the organization. And to do that, we have to do attack surface management, because you can't clean your home when the lights are out. So attack surface management is essentially trying to discover all the opportunities of vulnerability or of attack in an organization. And those opportunities can be created by the organization either through innovation or by new things being discovered. So the way we actually discover things is through continuously doing reconnaissance, continuously doing scanning, and continuously trying to discover what assets does the organization actually have. And we try to identify dark data, so data that have been forgotten about, and shadow IT. And what we're trying to accomplish is we're trying to find those paths that are least traveled, because those are the paths that are most interesting. Because what we want to accomplish is we want to know the customer or know the target better than they know themselves. We do accomplish that. A lot of organizations don't really know what they have in regards to IT infrastructure, and especially not if it's a larger organization, because then they often have sub-organizations who start create a new website. Is that allowed? No, not really, but they still do it, and that exposes the organization to a potential vector of attack, and it also is a financial risk. What we want to try to do is we want to try to mimic the attackers. We want to try to do what they do before they do it. So attackers often try to get in via the road less traveled, so we want to do the same. It's really inspired by bug bounty hunters who go to companies like Meta and try to figure out how can we hack Meta. And as you might imagine, there's a lot of people trying to get into Meta. So you kind of have to find ways that people haven't looked at. And the way to do that is we have to have the best recon. So we have to have the best processes, we have to have the best word lists, and we have to continuously and always be on the lookout for new opportunities, both in terms of potential attack surface that they have, but also in terms of new vulnerabilities that might be released. So that is really the key to becoming an advanced persistent team. It's assessing continuously the risks and opportunities that arise in an organization due to them changing or new things being released. It's about weaponizing CVs, so weaponizing commonly known vulnerabilities and exposures. So finding the information that's released about new vulnerabilities in software and using those to try to be before the attackers. So instead of doing week-long engagements every half a year, we want to do micro-engagements. So every day we do small tests. If something changes in the organization, we test that and see, can we exploit this? Is this change dangerous for the organization, or is it okay? And we can see the same kind of persistence and same kind of activity being done by successful bug bounty hunters. So we can get a lot of inspiration from them, and we can also learn a lot from how they do things. And we have learned that, and we have created our own systems for supporting that mission. So one thing that's really important when doing or when becoming an advanced persistent team is to have high fidelity alerts. So when we're creating an issue, the customer should know this is something they should care about, because a lot of companies and organizations create issues for things that doesn't really matter, that doesn't really affect the security of the organization. Does it matter that they have an outdated SSL certificate or SSL version that they're utilizing? Yes, it matters if your threat actor or the people you think are going to attack you are nation states, but if you don't think that's the people that's gonna attack you, it's not really relevant. So then maybe you should focus on other things that are more relevant for you. So that is why we kind of built an offensive security center, and an offensive security center is basically the same as a offensive security operations center or SOC. So we get in alerts. The SOC, which is from the defenders, get in alerts for security issues. Maybe someone has clicked on a malicious link. They will get alerted. However, in the Red Team Operations Center, or OSOC, we get alerts that are produced by our offensive services. So we get alerts that say, hey, this new domain has been registered, this new application has been released, and then based on that alert, we test it. And that's really what persistent penetration testing is all about. It's about testing things continuously. It's about testing applications when they are discovered, when they change, if they change, and also monitoring what vulnerabilities exist. Are there any new vulnerabilities that could be exploited? And if that's the case, we should warn the customer about it. And lastly, it's of course kind of having that high level of fidelity and high level of reporting of issues and reports that makes the customer actually act on the reports you send them. Because if you send them a lot of things that doesn't really matter, they won't spend time and focus when you actually tell them things that do matter. We have had cases where we told an organization, hey, you're vulnerable to this, we can hack you now, and we will get remote code execution, we can run code on your machine. Please fix this right now. Did the organization do it? Some of them did, but the one that didn't, that spent maybe a week trying to figure out who owns this system, those got hacked because they didn't act fast enough, because it's important to be fast, because applications, when they change, they could open up for vulnerabilities. So, and kind of the results from having that OSOC and having that continuous monitoring is a dashboard where organizations get insight into what issues do they have, what threats exist, what threats might be relevant for them, and it also allows them to get some compliance checkboxes done. It allows them to have an asset inventory, which is probably better than the options that they had previously. They get the ability to say, yes, we do monitor vulnerabilities that are being released, and it also allows them to react faster to emerging threats. And a lot of organizations find this really useful, and it is really important, because the old way of doing pen tests doesn't really work anymore, because attackers are too fast. Thank you.
Much for your talk, Simen. It was very enlightening. Thank you. It's very interesting to hear about these topics, because I feel like cybersecurity is something that just kind of like goes on in the background and you don't really hear much about it, even though we are using these systems every day. So it's nice to get some insight on that. So I think we are finished with all the talks, and we can get everyone from UiAdoc up on stage.
Yeah. Dear guests, esteemed speakers, and valued participants, as we conclude this remarkable Young Researcher Night, we would like to take this moment to express our deepest gratitude to everyone for being here tonight. In a special way, we thank the rector who was here with us and all the faculties at UiA, because without their support and encouragement, this event could not happen. So we are so grateful to them. For our incredible speakers, it's with a grateful heart for them to share their passion and expertise. I hope these contributions have not only enlightened us, but also inspired us as young researchers, and I hope in future we'll use these insights they've shared with us today. We are so grateful for their contribution. For the enthusiastic audience, help me to give a big applause to yourself, because without your presence, this event couldn't happen. So big applause to everyone. As David also highlighted at the beginning, we gratefully acknowledge the support of our esteemed partners, including Young Researchers Academy of Norway, Center for Advanced Study, and Berg St. Stilfelsen. Sorry for my Norwegian, we have Johannes there. So their support has enabled us to organize this event, because they support us in different ways, financially, technically, so I cannot give all the details. We are so grateful for their collaboration and generous sponsorship. As we close this event, we are honored to have been a part of this Young Researchers Night, and we hope you will carry the connections and insights gained tonight with you throughout your journey. Don't tell me that you have left, you will leave here without at least connect with one person, because this is one of the main goals of UiAdoc, to make new friends across UiA, and maybe in future you never know where you will meet again. So we will be grateful to hear that we meet in Italy, because we met first through UiAdoc. So we are so happy for that. So thank you, and we wish good night for everyone. Thank you so much. Now the event is closed. So thank you.
Thank you for participating. Until then.